here if you need to track your attendance. You can enter that into the app. With that, we'll turn the time over to you.
Thank you very much. I will kick us off. My name is Simon Lewis. I'm the Transportation Asset Management Lead for AECOM. I was formerly head of the GIS for a number of years, and then I went to the dark side and worked with vendors rolling out solutions. And Michael, would you like to just say a couple of words?
Sure, I'm Michael Warren. I'm the Associate Vice President and BIM Director for Transportation for AECOM for the Americas region. My focus is basically on digital innovation, digital transformation. We're part of a group that's identified as digital practice and technology, so the focus that we key on is innovation with the use of technology. So AECOM has over 10,000 softwares in our technology stack, and our job is to manage, maintain, and integrate data between all of those software solutions. So our agenda for today, there's going to be 5 components. Hopefully we'll have time at the end for a group discussion. But the information model vision, impediments and challenges, delivery solutions, where we go into key components of delivery solutions for the architectures. We'll have some examples from some projects between the UK and the United States where we've used what we're going to talk about with the data architectures and how we've implemented information that we've learned from the vertical world and translated that and applied that to the horizontal world. So it's going to be a little bit different than what you've seen in other sessions, but it works for us at AECOM globally, worldwide, and it's a very systematic, semantic approach towards the architectures that we do. Simon?
Thank you. We in AECOM, perhaps you and your organizations, take a safety moment. And one of the main ways that we can save lives on the roads is reducing tailgating. In this little example here, it's a very cheap, cost-effective measure. You put dots on the road so vehicles at a certain speed will know if they're at correct braking distance behind. So that's our safety moment. Not all states do this with DOTs. We've got big DOT and little dots here to, excuse the pun, but they won't get much better. So topic number 1, we thought we'd start with the vision. And this conference has laid out a lot of the vision. So we needn't go into it too much here, but we'll just highlight some aspects of it. You've probably seen this diagram many times at this conference. It's from the Federal Highways BIM manual, but the basic idea of collecting data once and then reusing that throughout the life cycle. Now, some of us have been around quite a long time and came to HEEPs in the 90s. You know, we're kind of here with historical, but we've had this vision a long time. It's delivering it has been the real key challenge, and understanding some of the different data sets and the conversions that need to go on through this life cycle. And one of the things that we'll pick up on in this workshop is, while the vision is relatively simple of birth to death life cycle data management, the reality of the semantics, whether the data item at the design stage is the same at the operations and maintenance stage, whether we're managing exactly the same thing, is one of the things that we'll be talking about.
So it's interesting for us is we have a paradigm shift going on inside the company with our digital transformation. And this is what we've learned from working with our clients. And the idea is we go from concept to design to build to operate and manage. And what AECOM stands for, it's an acronym for Architecture, Engineering, Constructions, Operations, and Maintenance. And those are the functions that we do inside the company. So we provide all those services to our clients. What's interesting for us is all of the circles that you see around the outside all have their own architectures. And they all have their own software solutions. But we had to figure out a way, as Simon said, to move that data, that single source of truth, from one aspect of design all the way through to construction, all the way through to asset management. So what we do is we think with the end in mind before we start. So the goal is we're setting up our models, we're setting up all of our information models with the ultimate goal of delivering asset management, okay? And through that life cycle, it takes a lot of work on the design portion, but also collaboration with contractors to get the appropriate information. And I'll be speaking about a semantic language from the construction world that also advises asset management. So, data to wisdom. You know, for us, it's data, information, knowledge, and wisdom. What are the digital inputs? We have to answer the questions, we have to make decisions, and then we have trade-offs. So the idea with the AMIS support scenario is we look at decision support, which is analytics, algorithms, and rule-based automation. So that's the key function behind what we do with our data architectures. And you can see in the stovepipes, you know, just various examples of what we do at each of those phases whenever we're taking data and trying to utilize that data for wisdom.
David Duncan in the back of the room with Federal Highways, and I used to work with a predecessor of his. Federal Highways in the 1990s put out a 3-day workshop for state DOTs. And the title of the workshop, it was really a program, you could pick modules, was called Integrated Transportation Information Systems. And the basic issue that we were trying to deal with way back, I mean, it's very exciting for me to be at this conference, you know, thank you, Utah, for doing this, because I'm now seeing the realization of addressing some of the issues here. We can't forget the organizational piece, that in Western society, compared to, say, Asian societies, we're used to working in small tribes, no more than 30 people. And we've not yet learned to fully do these enterprise kind of efforts. Sean Blessing and I have been coordinating a FHWA supported peer exchange on enterprise data lifecycle management. And we had a lot of breakout sessions, and one of the key things that people said in those sessions, you know, I believe in the enterprise view, but give me enough money, I'm going to go in a corner, I'm going to have my own data standards, my own technology, I'm going to, you know, just do it my way. And, you know, that's the way sometimes things work. Of course, whoops, wrong way. So the vision has always been this, you know, that you can share the data. I thought Abhishek yesterday gave a very good session on modeling data and the data dictionary, coming up with common definitions so that we can share. But even he said it may take us 100 years to actually decide a definition of something like a route that is common across maintenance, across snow plowing, across construction, because the drainage view is different from the pavement view, from the snow plow view, and we've got to start at the common gore points or whatever it is. Usually what happens is every data collection cycle that's done by a pavement vendor is done a little bit differently. So to come up with the organizational perspective is really where we've been going. I think this is from MinDOT, the peer exchange that we did. We'll just give you a couple of cuts here. We'll get more into the depth later, but the vision, again, of these common switch yards of data coming into a digital twin or common data environment where we can reuse that information across. But we also need common definitions of all of these things. I've worked with a number of DOTs like, say, CDOT next door, and we've got all the assets now in the asset management system, major accomplishments. But we've also got to do things like commonly value the assets across the different asset sets, because if I'm doing costs for the Eisenhower Tunnel one way, and I'm looking at costs, I've got to be inclusive costs, the cost for pulling all the old assets out, putting in new, all the way through. Another cut, this is, I think, from Sean in Iowa, again, the idea of trying to take a holistic view through all of this. And I've we've got some clients, you may not be able to see this very readily here, but this is a technology stack that you can imagine. And I've got some clients who actually have a lot of this technology stack. If you imagine starting with the asset at the top of the stack, maybe in the GIS system, there are some vendors where you have to have an asset before you create a work order, but other vendors no. But as you come down the stack here, maybe work orders are the thing that alters the state of the asset as you come through the system. But really, again, trying to come up with an architecture for the agency, how all of this plays together.
So here's the interesting part. We've all have a different definition of what a digital twin is, okay? I don't think anyone's going to agree. But to demystify that, at AECOM, it's not a 3D model, okay? It's a physical digital entity in real space, meaning geospatially referenced in a digital world that matches the physical entity, and it works inside of an enterprise management system. So it's a framework that links all of the data together, okay? It's not just that 3D model, and that's what you keep hearing about. It's an actual enterprise system of data that comes together, that talks to each other. The beauty of the 3D model is it's object-oriented programming, so they're databases. They're relational databases. And those objects can carry an infinite amount of information. So some examples, simulations, record document of the physical asset in digital form, framework of intelligent engineering queries without physical inspection, that's key. And I'll be talking about that a little bit later. The digital twin can be acted upon as a database. So with that in mind, again, getting away from the 3D model concept, it's a series of relational databases that are linked together through element or object IDs. So that, just like I was telling Simon yesterday, if you think about how you deliver mail or how your mail gets to you, right? Street address, house number, name of the street, zip code, city, right? Those are hierarchical systems for data management and data movement. If we start thinking about the digital twin in the same way, where it's a system of architectures, you can truly get into real-time data capture for IoT sensoring, SCADA systems, other things, and geospatial monitoring. So data architecture to us documents the organization's data assets and how data flows through its systems. So, you know, a lot of people get confused sometimes when they think of data architecture, but to us, enterprise architecture that includes the organizational model, the technological models, policies, rules, and standards that govern how data is collected, stored, used, arranged, integrated, are all part of managing what meets the business need for the organization. So whether our clients ask for it or not, this is the way that we function. This is how we operate. This is what we do whenever we perform our work. So simple Venn diagram. This was developed a little bit earlier this year through the AED-80 working committee. But when we think of architecture, there's three key components towards what we consider a digital twin: asset management, geographic information systems, and then the BIM, or the digital delivery of all of that information. We started to get away from using the term BIM inside of AECOM. We call it information modeling. Simple, pure, that's what it is. Doesn't deal with the building. We also have an acronym for civil infrastructure information modeling, which is the horizontal side. Too many acronyms. It's just information modeling. But in doing that, when you're looking at the digital delivery, you have to have organizational and institutional goals around the data, business processes, and you also have to consider technology. One of the big issues when you're talking about a digital twin in a very robust database management system is that data lake or that data storage. These things take up a lot of space. They take up a considerable amount of space. And a lot of times our clients don't have the capabilities or the wherewithals within their systems to handle the amount of data. So we host that for them, and data mine that. So here's some better information modeling workflows and software examples. The keys here isn't the nature of all these little symbols that you see flying around, but it's data capture, it's concept modeling, it's inputs and outputs, design authoring, parametric modeling, clash detection, visualization, environmental concerns, fabrication, but mostly data management. We focus on, and my job is to focus on, when you look at this diagram, how are we moving data across all of those delivery stovepipes from all of those different software solutions? And there are architectures behind how to move that data, and I'm going to speak to that a little bit later, the basic core of how we move information. So with an integrated information modeling workflow, DOTs have digital data archives, but the information deliverables is what is key to us. So document, data, and model-based information. So we have project information and asset information. So we have PIMs and AIMs, right? So they're two totally different types of models. One gets developed prior to the other, but we look at that simultaneously. So as we're developing a design, we take survey, preliminary design, detailed design, construction, as-built, and then updated as-builts. All of those phases are built out inside of our architectures before we start. So the information is there and it's readily available to the entire team. It's not a single handoff.
Thank you. We're not going to spend too long on this session. I'd like Michael to be positive and show us solutions, not problems. But it's sometimes good to start to know the potholes and the hedges you've got to get through. Because sometimes I think as a community, we can overpromise the vision and not deal with the shop floor reality. So we'd like to just briefly touch on some of the challenges we've got in the field here, just so there's a dose of reality that we can deal with. And again, I'm drawing on this workshop I'm doing with Sean Blessing of Iowa DOT, where we have about 15 different DOTs. We've had 4 half-day work sessions. We're going to have the day 5 shortly. I won't go through some of these challenges. You probably know them in your agency, just talking to you beforehand. I mean, even getting people to come to these meetings and take notes and agree, can be some very basic problems. So I won't read all of these out, but I'd just like to say that we have learned some lessons. I started around 2001 with the VDOT asset management system. Ended up in a rather unfortunate learning exercise, shall I say. But now, after so many years, most state DOTs have some sort of asset management system up and running. And we can learn from parallel technologies as we get into digital. What did it take to actually get that thing to work as an enterprise? Well, if there's one bullet I'd highlight here, which is very obvious, but it just needs underline, is that all this digital stuff is not just technology. It needs a wider architecture to make things work. Again, we can go through all of this. These were some of the questions that came through that workshop I did with Sean. I mean, some great questions came out. Like, we always think of data silos as being bad. Well, sometimes they may have some utility. People may not want to share information because of legal reasons. They may just want to get in and out of it. There's some reality checks that we do need to do here. Because we've got limited time, I won't go through all of this. But Michael, perhaps you could just highlight from a particular BIM perspective some of the impediments.
Sure, there's basically what I found for all the years that I've been doing this, and I was an early adopter of BIM, started in 2000, right, and have been working in it and developing it since then. Clear documented strategies, robust planning, implementation to the right technologies, training and development, continuous improvement, and communicate where appropriate. These are the problems that we find when people adopt BIM. They're reluctant to do it, okay? And it's because of these factors that BIM gets overlooked. And we've analyzed and discussed it with clients, had many presentations. I've presented it at tons of conferences on this topic. And back in 2000, when the building industry started doing it, there was a lot of hesitation. Now we're doing it in transportation, and we're still finding hesitation. Part of my role is to write execution plans for all of our DOT jobs where they're requesting models. There's still pushback. There's still pushback. What is the benefit that I'm going to get by hiring or paying you guys to build me a model? So combining the data, clients are now asking for greater levels of graphic detail in 3D models, okay? And I'll talk to that in a little bit. It's called level of development. But we have to have a need for a consistent approach, for example, to drainage data for design, construction, and handover, right? Oftentimes gets overlooked, but it's a very critical factor, and I was speaking to someone about that last night, right? We can simulate drainage runoff all the way through to a watershed if you set up the right system correctly. Takes a long time to get complete hydraulic design, into a construction model. I'm going to show an example of a project that I'm working on now that's an as-built of the project, but one of the things we utilized the model for was computational fluid design. Any of you use that in your organizations, or focus on that as part of your requirements or deliveries for validation of a design? It's important because by doing that, this is a drainage system for a very large highway segment. With CFD, we were able to find out where we were going to get a geyser effect with too much water. So design iterations exacerbate the time to completion, which lead to the delayed programs and cost increases, and a high skill level is required in modeling tools to achieve client expectations. These are the problems that we found from Roads UK, okay? And I'm going to be demonstrating this, but National Highways in the UK, very large project that AECOM worked on, but they had very, very stringent requirements on the delivery, but these were some of the problems that they identified to us early on. So,
thank you. In this slide, we just very briefly compare asset management and hopefully can read it in BIM. And the idea here is we've got two technologies that we'd like to play together. Some people would say that doing all of the digital, the ultimate goal is to reuse all of that data collected at the design stage all the way through to the operations and maintenance phase. But we've got fundamental issues here that the size of the data models, because the resolution in BIM is so large that I've got PennDOT with about 40,000 miles of road or whatever, because they manage all the roads in the state, it would be 40,000 BIM models. And so you've got a tractability. So do we think of more BIM as to give us the opportunity to do project level dive downs is one of the questions. Another question we have is that all state DOTs manage their highway street furniture through linear referencing systems. At the GIST symposium, we've been doing linear referencing system workshops, how to do that for many years. 1.5D is not really a metric that at least to date is represented in the BIM models when we go 2D, 3D, 4D. What about 1.5D, which is, with Roman centurion standing on Hadrian's Wall, Scotland, knew he was 1911 melee from military miles from military paces from Rome. So we've got semantic issues of how this fits together. So Michael, I'll flick the next slide. Tell us a little bit about the ontology problem.
Sure.
Here.
There's an ontology issue that I found in the industry, and it's that differentiation between what we can learn from the vertical world and how we use it in the horizontal world. And I use this slide and I present it all the time because that shape, right, that I-beam is a girder, it's a beam, it's a column, regardless of if it's a building or a structure that we're building on the highway. However, it's not looked at the same. They're not treated the same. Why? It's a semantic issue. They are actually the same thing. They have properties, they have attributes. It's how you define those properties and attributes for the use case when you're putting the architectures together for what that object actually does.
So we've got kind of the same story when we now model highways. On the left diagram here, you've got chainage as the highway was designed with curves and various geometric entities that you would use to design the highway. But now I pass to GIS. Short version of the story is you don't have curves in GIS, or at least not in the plain vanilla version. So you're losing information as you transfer one to the other. And the chainage that you might have had here going in one direction may be different than the linear referencing system that was applied to the GIS segmentation. They started at a different gore point. And then when we go to the pavement management system, there's another segmentation that's going on there. Now, these different realities, or way you can look at reality, is ultimately addressable, but it's not always simple, because every state DOT does linear referencing systems, as you can imagine, a little bit different. I haven't found two DOTs who do it exactly the same. So we need to generalize some of our solutions here. So hopping into the next section here, we're going to look more now to solutions. We've just briefly highlighted, we're putting a lot in front of you today, but three components of solutions. We don't want to be just stuck in what some of the challenges are. And we're going to look a little bit at enterprise framework, which I'll briefly touch on, and then Michael will give you some meat on methods and data models. So one of the things that we argue, and we've been arguing this at IHEEP since about 1997, is that you need, if you're going to do these enterprise activities, you need an enterprise framework where you can really take a look. You see many diagrams like this across the organization, which really starts at the top with your business drivers, and really the technology infrastructure should be supporting things upwards like this, and you account for the different views of asset owners, managers, planners, all who have these different views into the data sets. Well, back in the 90s, I actually gave a workshop at IHEEP on the grandfather, ultimate granddaddy, enterprise framework of all time, which is the Zachman framework. And it basically creates, won't have time to go into it here, just a couple of slides, but a classification system for any major endeavor that you're doing in the agency. We've used this back in the 90s when we did GIS in DOTs. We used it for a couple of agencies like Virginia and Maine, who then went and did data warehousing. That was the hot topic at the time if you came to IHEEP around then. And what it does is provides a classification schema for all the activities, answers the questions what, how, when, where and why, etc. in the organization. Now this takes some mapping out, and I won't have time to go through this in detail, but there are different models, different lists that you create to try and get a handle on overall organizational. Dave, you can take a picture of this, but Federal Highways supported the development of this back in the 90s. This was work supported by Federal Highways. And here's a blowdown on the what, some of the models and some of the things that you get into it. Now, the federal government has a version of this, enterprise frameworks for when they're doing major system implementation. But the short version of the story, you can go look up Zachman if you're not familiar with it, is that in my experience, this is such a complete classification system, it's overburdensome. I don't know any agency that's actually fully done Zachman. So what we did, and this looks complicated, but actually back in the 90s came up with a simplified version of Zachman, which, as much on here which you won't be able to read, it's basically called the four-pillar methodology, and we use this to support GIS implementation in 24 DOTs. And the difference between this and Zachman is that Zachman is really a classification schema. Here's a lot of things that you need to make lists of and catalog and do all of this. This is a methodology, and I'll show on the next slide, but basically you start at 1.1 here, sorting out some organizational and institutional things and work down towards technology, which I'll show on the next slide. So this is based on a lot of consultants. This isn't just, unique to AECOM. I've used this in 8 different firms, and a lot of my fellow consultants in some of the other firms have a very similar. We've just found as practitioners, you need to address organizational and institutional issues, and there's a set of things under that need addressing. There's a standard set of data things, and here's a top 10, they need addressing. Here's best practices, here's what it costs, here's example agencies, boom, 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 boom. And so by doing this, we can provide upfront a roadmap, a detailed roadmap of how you can do, whether it's GIS or data warehousing or BIM. And we're coming up right now, some of us consultants who use this or similar frameworks. And what we're doing is drawing on the 12,000 pages. I mean, this is just in asset management, the ISO standards, the IAM Institute of Asset Management, the IIMM, which is mine, the International Infrastructure Maintenance Manual. You haven't got time to read that lot. We can populate this and give cross-references to this, so you're good to go quickly. Most people want to know the end line at the beginning, so by HEEP, here's the roadmap. Start here, come through, follow here. So just a quick example of that. This is more detail of the top 10 things in each of those 4 pillars. And again, this is one framework. You'll see even in the Federal Highway BIM guide, they have a similar 4-pillar. People label the pillars slightly differently, but it's essentially, and this is really applied common sense, that you basically need to address organizational, institutional issues. We found by experience, Becky Helm leaves UDOT, you keep going when things do good, but it's a big loss if a key person goes. So you're addressing some of these issues up front. You've got to have a leader. And then performance measures. What are we trying to get out of this thing? It's not always clear. So we kind of know all the linkages as well. So this is a basic methodology. If you're not using this one, fine, but we argue you do need a game plan. You don't go into a football game. I don't know American football, but I believe they have all these little sheets that tell them, the plays and all of that. Well, you need some of that. And then when you do this, we can go into these kind of spider charts or radar diagrams where you compare yourself to national best practices. So Utah may be a national leader in digital, but maybe CDOT next door is just possibly a little bit ahead in asset management and developing all 11 asset categories. And so, we can provide here where you are today versus a national best practice example, so that you kind of can see where you're going. So that's just very quick plug for having a roadmap. And now I'll let Michael get into some of the meat on the methods of how we actually deliver this.
So, who's familiar with waterfall and agile project management? Now, by show of hands, how many of your organizations are still operating under waterfall? A little bit. Agile project management is really the way to go about tackling this data architecture, data movement, data structure focus, okay? And in waterfall, everything is linear. It's the engineering approach. I have to do this before I do this. And then before I do the next step, I got to take care of this. Whereas with agile, you're actually moving through a system multiple times. It's an iteration. So conception and initiation can be treated together, But when you're conceptualizing, you're also thinking about maintenance and deployment. So you're not going through step by step by step to answer the problem. You're looking at all of the problems with a very iterative approach. So for this to work, you have to have data validation. And the key assets that we look at are the big six, right? Asset definition, condition, age, install year, okay, value, decay curves, and treatments. When we do that, we're looking at the quality dimensions for the fitness for use, okay? So how complete is the data? How unique is it? Is it the timeliness of it, the validity of it, the accuracy, and the consistency? We always look at this with regard to all of our data with all the architectures that we utilize. These are key. Purpose is development, quality assurance, acceptance testing, and production. Quality assurance is critical with data validation. So when we start thinking about data models, this is an asset hierarchy tree. This is typically how I have to start every BIM project that I deliver, okay, for a highway. What's important is we look at ITS, we look at tolling, tunnels, bridges, roadways and appurtenances, equipment and fleet, facilities, fire and life safety, and then SCADA systems. They're all considered, but you see all of these architectures under there. Those are all the things that have to be put into these models for them to talk. So we've standardized this information. We've built templates in our software packages. We've written programs in Python that allow us to impregnate all of our data models whenever we start a project to consider all of these factors that relate one to the other. So when we think about a data warehouse, these are the factors: business analytics and the semantic layers, okay? So, you know, you can see just there, the business analytics are important. They're key drivers. Things like KPIs and dashboards and analysis go through to that semantic layer that feed into your assets, your work orders, RFIs, okay? The maintenance of all that data. That has a purpose, it has a function, but it can be tied back to the physical objects inside the enterprise data warehouse, which is the conglomeration of all of that digital twin that I was talking about. So we have analog and digital information management. The key here, though, are national standards going through the stages. And ISO 19650, people have been talking about it a lot. Not followed here in the United States, followed pretty much around the rest of the world. It was something that I had to get AECOM to adopt 7 years ago when I came. We had to learn from around the world this nice standard of managing BIM data and information and reference that and how we actually execute work and do the work. But we talk about federated information models, structured data, unstructured data. What do you do with it all? You know, big data. We refer to it as mega BIM, okay? And for us, there's a difference between mega BIM and we also have a term that we call cadaver BIM. And the cadaver BIM is just that 3D model, that pretty picture that contains some information, but not all of the information that you need for a true digital twin. So here's an example, data workflows, and this was something that we did for Crossrail over in the UK. But we had GIS workflows, we had documentation workflows, and then we had our CAD or model workflows based on object-oriented design and processing. But we had to bring all of this information together. To accomplish that, we had to have architectures and we had to understand how to move data from one place to another for a single source of truth. Crossrail was a huge project. Tens of thousands of documents, thousands of models. But we were able to be successful pulling all of that information together by having that enterprise, you know, common data environment or connected data environment to store all of that information. So the ISO 19650 standard, I think everybody here knows what it is, but the goal to us is it increases the efficiency of information processes, improves the clarity of the information, and it facilitates better collaboration. Those are the keys. And it is applicable in the horizontal world even though people think of it as something that was written for the vertical world. The standards still apply. These are the associated relevant standards that are applicable to ISO 19650. So when we're talking about looking at just that ISO document itself in all three parts, these 18 other documents have to be part of the discussion. Okay? We're talking about quality management systems, data quality, industry foundation classes, project management, organization about construction works, systems and software engineering, information technology, risk management, asset management, document management. All of these things tie together. So at AECOM, many of you probably have seen diagrams similar to this, but we have 8 dimensions of utilizing BIM going towards asset management. 1D, which is conceptualization, 2D, which is conceptualization, but we start to bring in vector data, and that linear reference system that we talked about earlier, that 1.5D carries through all the way up to 3D, where we start to talk about form and function. What's critical here is all of these elements that you see under here are part of the architectures of the potential uses of what you do at each one of those phases, what you can do with that data and that information. So we take the first 3, translate that into the 4th dimension, which is time, schedule, and implementation. But then there's more. Finance and cost, sustainability and performance, maintenance, preservation, safety and risk. Now, there's new studies out going up to 10D and talking about that, but you know, the key here for us is 7D and 8D really go into the asset management world. They work together, okay? So the idea is the life cycle simulations, and again, these are uses and architectures behind each one of the functions of what you have going on. But whenever we start to look at safety and risks, do we consider maintenance, inspection, as-built capture, right? Hazard evaluation, performance evaluation, risk mitigation, operational and budget comparisons, as-built modeling, life cycle simulation, energy performance, systems performance, continued cost-benefit analysis, and then again, going through that life cycle evaluation. How many of you are doing steps like this or something similar to this with the data that you have inside of your organizations? So there's a very strong key here behind the frameworks. Now, this is to us where we learn the lessons from the built environment, the vertical environment, and apply them to the horizontal environment. How many of you are familiar with ASTM Uniform At 2? Okay? It's a standard. It's a semantic standard. And it covers everything from a system classification, okay? So we're looking at systems. And many people tell me, well, you can't use it for anything horizontal. Yes, you can. There's a whole grouping, and I'm showing it there. It's referred to as building site work, but there's a structure. This structure goes out to level 5, where you're starting to define the classifications of the systems that tie together. And then this larger chart shows the uses of what you do by classifying things inside this system. So as I was talking about before, the way we frame and start is we define a system. So if we're talking about a roadway, as I was telling Simon yesterday, all of those components or aspects of a roadway in the digital world are part of a corridor. So we have to define them at the system level before we go here, the object level. This is where the rubber meets the road, and this is called OmniClass. Who's familiar with OmniClass? Okay? How many of you that are familiar with it are utilizing it inside your projects? Okay. Nobody. What's interesting here about OmniClass is this is how you start to define those objects and those elements and those data architectures, where you start to drill down. And you can see by the various list of the information on these tables here, there's something to consider throughout the whole life cycle of a project. How data moves, organizational roles, where data goes, spaces and objects by form, by function. They're categorized. We put this into all of our models. So we have a system level and then we have an object level that we utilize. And again, it's a standard system. And this is how it works. Various tables work together. They go in conjunction, and then we use those OmniClass tables in an Excel or CSV format, and we import that data into all of our data models and our lifecycle models. So it's another semantic layer that's added on to the data architectures of what we use and how we function. And we found a lot of success with this because it's clear. It ties into the database and it links the information together. Who's familiar with Kobe? You guys utilize Kobe? Okay. Again, another lesson learned from the vertical world. It's a non-proprietary semantic data set used in construction. So the constructor is actually taking data and inputting data from their processes into that digital twin. And by using that, it's moving you closer towards a true asset management system. And as I said, it's semantic. And I'll be talking about the semantics of these architectures because it really breaks down to 3 file types. And that's what people miss. There are 3 basic file types that you need to move data through any kind of a digital twin. So what we've done, starting at ISO 19650, is we go through what we call smart assets and their capital efficiencies, and we developed this for our projects in the UK and over in Asia. But we call it a digital estate, where we take the BIM, the GIS, the PMO information. Again, to us, that leads to the digital twin. It's not just a 3D model, but then we put that into a larger estate. And by saying a larger estate, it gives you the ability with the frameworks that I've identified that you can go into your database systems and actually scan, analyze, or get data off of entire systems. So it's important to have those hierarchies in place. This is the implementation roadmap that we delivered, right? And the steps of how we go through to get better systematic knowledge and capture by data and data reuse. So there's goals: strategic definition, preparation and brief, concept design, develop design, technical design, construction, handover, closeout, and then in use. The goal here is better operation. So if you plan with these architectures in place and these data structures in place, you get better operational outcomes. You get better results, okay? And the information is validated and ready for your asset management systems. So the data paradigm, this comes from Penn State University. They're one of the leaders in developing the BIM roadmap, so to speak. But identify the BIM uses and goals, design and execution process, develop the information exchanges, and define a supporting infrastructure for developing BIM. So those are information models, right? There are steps, there's details, there's processes, there's diagrams that go into this. And what I find on my larger projects, we're doing a lot of progressive design builds right now. These steps are very confusing when I give them to the owner. So we usually have to have meetings with them to describe to them these processes of how we're going to benefit them by developing these BIM models for their entire systems. So for us, it's a matter of combining the data. And we have basically a system where we organize that data, and this is just one example of utilizing BIM for infrastructure. Alignments, the hydrology, ITS, right-of-way, roadway, structure, survey, the templates that we use, terrain models, traffic control, and utilities. Those are just the foundational elements of creating these enhanced, enriched digital twin models. But we have to have a hierarchy of the data to search it. So we use PowerShell to search inside of each one of these folder structures. So this is another example going a little bit further to what Simon talked about, where you can take GIS, you can take your CAD, you can take your BIM, all of it has a purpose. So what we do, for example, with GIS is right-of-way, property boundaries, alignments. Repurpose that information into our design systems. That's the foundation of what we do. Then we move to the CAD layer, where we start to get into the definitions of the break lines and points of intersection, okay, survey information, survey data that gets brought in. It all has a purpose and a use. But then whenever we go to the BIM, we're taking that data from those single sources of truth and implementing that into a functional, realistic model. So level of development. You guys familiar with this term? Okay. This is the big issue. This is where when I talk to agencies, there's always a debate. What am I going to get? What LOD are you delivering? What are you talking about? And what am I paying for? Well, you're paying for data. The more information you want, the higher the LOD. That's the bottom line. If you want and need all of that information, it costs money because we're talking about data. So in the design world, we typically stop at LOD 300, which is accurate information. Hand it over to the construction side, fabrication, that's where you start to get to these higher levels of development. But now we're starting to see, for design of bridges, we're going to LOD 350 and 400, because now we have the capabilities to do that. So we're showing all of the rebar. We're showing all of the bolts in a steel bridge. They're all defined, they're all geospatially oriented, they all can be referenced, but they're very precise and exact. So the term better information modeling, new, started coming up a couple years ago. It's kind of the new BIM. Some people also call it better information management. But the idea is, to us, the BIM, the SIM, and the BRIM all come together. And it's the usage and model governance to document the infrastructure design, construction, and operations. So data transfers from BIM to AM. Clear data policies, data classification, data quality management, data security, data privacy, data retention and disposal, and a data governance council. How many of your organizations have a data governance council? Is it working?
No. We literally just started.
Okay. How many of you have a data retention and disposal policy? How long traditionally do you hold on to information? Indefinitely? Okay.
Depends on what it is. Some construction information is only 3 years, others 20. Start getting in the design realm, that goes anywhere from that 20 years all the way out to the life of the structure. All the way with some of our historical stuff that's like construction plus 25.
Okay. And when you're thinking about these initiatives, do you have security policies in place, and do you have data privacy policies in place? Who can access what data? Because that's a big issue, right? We have it happen all the time. So I have to lock people out in our common data environments by putting rules or instructions or security policies in place to stop structural from going into, say, an architectural file and manipulating things because it works better for them. Instead of communicating and collaborating, they're monkeying around. At AECOM, one of the things that's very interesting is when we talk about structures, the abutments for a bridge are designed by our roadway team. That just blows my mind. So the abutments end up in the roadway models. They need to be in the model with the bridge. So we had to bridge that gap and get that communication together for the data classification to work out this. Geometry plus data goes to that wonderful thing, the IFC. So when people think of IFC, again, 3D model, wrong. It's also all of the data that we've been talking about this morning that goes into that IFC. That IFC can then be repurposed. Who's accepting IFCs now for deliverables? Nobody yet. Well, the great thing about it is it's a single source of truth. And I said I was going to talk about 3 basic file types: CSV, XML, DXF. With those 3 basic file types, you can get all of the information that I talked about, from systems to objects and elements to operations, and translate and move that data across seamlessly almost any software package that you have. And most people miss that. So you have the ability to export or get information out in these schemas, transfer them, import that data for purpose and meaning into other systems. So whenever we're combining all of this stuff for asset management, we move it through CSV, common separated values. Well, how do you analyze it? It's a text file, but you can analyze it in something as simple as an Excel workbook by importing the data. So when you start thinking about that and you're exporting that information in the XML schema behind all of that as a hierarchy and a framework, and then you combine that information with a digital exchange format or that 3D representation that's agnostic, that builds and leads to a better IFC. The other great thing about IFCs, we love this at AECOM. I started doing it 7 years ago when I joined the company. Model handover. When we hand over models and we translate models and we give models away at the end of a project, we write into our contracts, you will get an IFC. You're not going to get a DGN file unless you call for it. You're not going to get a DWG unless you specifically call for it. But if you call for a model, we could give you a 3D DGN, we can give you a 3D DWG, we could give you a Revit model. Not a problem. The preference is to give the IFC because the IFC contains parameters and information that cannot be altered or changed. So there's a chain of custody there. Who designed it? When was it designed? When was it implemented? When was it put in place? When was the system organized? But you can build on that. So horizontally, we're starting to get IFC definitions, but we had to build our own IFC definitions, and I worked with our programmers and our data scientists to build IFC classifications for highway projects. So we have parent-child relationships, that hierarchy that we add and supplement and implement into the IFC models. So putting it all together. Adopt an enterprise asset management framework that needs to also include your BIM. Okay? Those information models. Develop and formalize a technology architecture. What are you doing? How are you moving data? What is the purpose of the data? As Simon said, most agencies function in silos. So one group, design, doesn't know what's happening in engineering. Engineering doesn't know what's happening in maintenance. You know, but you have all this data, it's not connected. So you develop a strategy, integrating asset management and project management software implementation roadmap. Technology selection's key. Most people are going agnostic. How many of you are agnostic in your deliveries or going that route? Moving away from just using Bentley, right? The inclusion of other softwares, okay? So combining the data. So here's an example for using micro drainage as a system, but drainage assets. So when we start to get into all of these fields and what you see, the abbreviations and model types, these are the kind of parameters and attributes that we're adding to models. This is the information that goes in. It also comes out in that IFC. So we're developing these asset classes early on and enhancing through our data architectures how to get these systems put together and combined. So what we do is collect the data, unify the data from multiple sources, generate an integrated database, and then your queries and dashboards, better outcomes. So our focus is to utilize all of these different tools, put them into an aggregated system that can be looked at from all of these disparate areas, okay? As I said, that is the digital twin. But then you can analyze and get queries and take dashboards and suck information from all of those sources and compare it and analyze it. So here's the example part. This National Highways. And what you're looking at on the screen is an amalgamated model that was generated from GIS, the BIM design data, point cloud information, okay? You see all these layers that overlay on top of each other, but they all talk. They're shared. We had to model everything to LED 300. So you see the entire network system here for just the pertinent aspects of the roadway system. Very, very large, very complex model that we did for national highways. But all of the frameworks that I've talked about today informed that data model. It lives inside that model. It's collected, a unified database, okay? National Highways was blown away with the amount of information and data we were able to give them, but it helps them with operations. Just another example of the benefits of having a rich three-dimensional model. Parameters and attributes. We had to develop thousands of parameters and attributes on objects, okay? All of this information was translated into the IFC. So when we're talking about these drilled piers, okay, and the board piles, there's a classification system that we used. Parent, child. Under the child, many children, okay? And that's all of this data. All this data that's associated with that object that leads towards operations and maintenance and asset management. This is a very interesting project. I had the benefit of working on this. And I'm not gonna say where it is, but there was a forensic study that had to be done on a roadway because of a lot of accidents at this particular location. We went out and LiDAR scanned the information, compared it to design data. But the LiDAR was very accurate, so we used terrestrial LiDAR. We didn't fly with a drone. We weren't worried about photogrammetry. We needed to be precise, okay? Because we needed to understand why these accidents were occurring. From that, we built a digital twin. And what we found was the design information that was used is perfect. But the way the roadway was actually laid out and the way it was constructed was not as perfect as the design. Super elevation was bad. The curve radius, the speed rating, all of that had to be taken into account. Wasn't studied, wasn't analyzed. We simulated all of that with an accurate three-dimensional model of the roadway surface itself. And again, it was used for a forensic study due to accidents. This is Interstate 80 in Pennsylvania. So a very large project that we're doing for PennDOT. Full BIM, full GIS. All the data that I'm talking about is all inside this container. This particular container that I'm showing here is the iTwin technology from Bentley, the integrated cloud server, okay? But we use Autodesk, we have Esri, but all of this information was combined, brought together, utilized near maps for the very accurate photogrammetry of the underlays. A lot of information. Miles and miles of highway, but everything was modeled. Categories, model references, all the linear elements that are tied to that information that go to linear referencing systems whenever the data is exported, all with the intent and use potential for asset management, operations and maintenance, but very data-rich models. Stationing. People tell me stationing doesn't matter once it's done, it's only for engineering purposes. I disagree. It's my favorite project. I've been working on this project now for 4 years. It's a full BIM, it's in Michigan, I-75. Complete rehab, 8-mile stretch. The key focus of all of this rehabilitation, they said they wanted it modeled. So I got a 700-page manual from them saying what they wanted in their model and what the intention was behind utilizing the model. So I had to come up with strategy for doing that because we also were responsible for the as-built. And when we talk about digital as-builts, everybody says, oh, it's crap, it's nothing, it's not updated. No, this is updated. Because of all of that parameter information that I talked about earlier and put in, all of this is survey accurate. LiDAR scans for the surface, the boring of the actual tunnel itself, the individual tunnel rings. That's what you're seeing in the lower right-hand corner. The date, the ring number, the stationing of those rings was all important. This was something MDOT didn't expect. They love it. They love it because they know of the thousands of rings that are making up this tunnel. They know where everything is. They know exactly where it's at. But we also did something else. The boring machine was supposed to follow a three-dimensional alignment that was put in to create this tunnel. We had a design model for that. We gave them the information. They input that three-dimensional alignment into their system for tracking and how they were actually operating the machinery. But, as happens with all construction, the boring machine didn't follow that path. So I ended up having the model the actual bore and compare that against the design file. This was all for record purposes. But we were constantly clashing against the utilities, and we were constantly monitoring from that data coming back in the as-built. This is a living model. But the data that came back from that as-built, I would have to run additional clash tests to find out what other systems were going to be impacted by this thing not following the design path. So it was really important. The underlay, the information you see down there at the bottom, CAD and GIS. All data. But that's combining the 3D and the 2D in the real world and capturing that information. We're in the process now of taking right-of-way and other information and draping it on that 3D surface so you can physically see what's there. A lot of value. Combined model. One of the sessions yesterday talked about utilizing Esri's GeoBIM. We didn't do that. We built our own aggregated environment to get these models and all this data together. And that's what was key and important to us because we found the benefits behind utilizing this. This project was done using Bentley and Autodesk software. Michigan is a Bentley state. We had to get an exception. I told them, I cannot do what you're asking unless I can utilize both systems. So it's Geopack and Civil 3D. So with that, let's open it up to some discussion. Any questions?
In terms of being a digital twin and having a high level of maturity of digital twin and the model being dynamic, what are the issues that you can see with the implementation? Let's say that you have sensors installed on that bridge, you have settlement on one of the columns, right? And how can we implement that model change due to that settlement in that federated model of digital twin?
So we're doing that right now. We have a pilot that we're doing with Virginia where we're doing just that. Complex bridge. We surveyed the entire bridge. We built a digital twin of the bridge. We actually have another one that we did in Connecticut for crack detection. So we scanned it, took high-resolution photo images, but we built a digital twin and a replica, and they're installing sensors to monitor cracks and the movement and displacement. But when we do that, we also look at wind systems, loading systems, vehicle traffic patterns, other things, simulate that. So that's part of one of the uses of the BIM is to simulate. But as it moves, we're getting that real-time data from those IoT sensors. Taking that data, as I said, and then porting it back into the model, it's iterative. The model updates. So we have a condition that was before, then we have a condition that's after. And we put those states inside the model. So it's a living timeline that you actually see based on parameters. So we can go through that and say, where were we 2 years ago compared to where we are now? The model's updated.
And do you think that that could be done automatically, or we still need some interference from humans, right? If the model is changing, we have to do that manually, update the entire model again? Or?
We wrote some scripts. So there was human intervention. We wrote some scripts to remove the human error, because somebody has to interpret that data and analyze that data and that information. So we wrote some scripts in Python that handle the updates and the processing of that data. Are you guys familiar with a package called Dynamo or Grasshopper? Any of you guys using that in your organizations? Visual scripting. Really good, very powerful tool. Can do a lot with, utilizing that, especially in the BIM environment. So it's just, where do you collect the data? Where do you keep it? How do you tie it together? So even with the BIM models, we built reality meshes and other things that are all tied together, various deliverables. And again, we have to hold this information for the client because there's so much data there, there's nowhere to store it. I mean, our point clouds alone were, hundreds and hundreds of terabytes. Lance?
How you doing, Michael?
Good.
One of the questions that I had was, we've been building out for connecting to our model element tables, Omnibus and schemas, and we have to extend it out because it's not populated very well for the infrastructure side. We've got some basics, but
Mm-hmm.
you probably experienced that too. Seems like CSI's got to get you can send it to CSI, but if it doesn't end up too well, and you got to build it up, but you can still live in that framework. I just wanted to know what you guys were doing on that side. I think it's going to be.
I had to get creative. That was part of my responsibility, was to get creative, right? But when you look at it and you drill down and you look at those use cases, there's applicable use cases. But sometimes for board piles and other things with bridges and, like I said, abutments and other stuff, we had to use some building classification information and repurpose that. And I had to get the paradigms to shift with the design teams to get them to understand, no, you're assigning it there. No, but that's for a building. No, it's not. It's the same thing. It's the same thing. Just has a different use case, but it's the same thing. But for us to be able to classify that data and information with those models, we had to paradigm shift people's brains. And our BIM execution plans are massive. They're huge. For the progressive design builds, I have 4 or 5 volumes of execution plans. Because if I gave somebody one big massive volume that's 1,000 pages, they're not going to read it. They're not going to focus on it. So we had to break it down into palatable pieces and chunks and bites, but explain all of that. So normally, Lance, I have to have meetings with the BIM team and the designers and focus on how to enhance and enrich this data so we get the full life cycle output. Bill?
Michael, your thoughts on, so, typically at DOTs, right, our portfolio of projects go from, mega BIM projects, billions of dollars, down to millions of dollars.
Mm-hmm.
And what are your thoughts on how we progress into this venture with those, with that type of portfolio, with the smaller projects?
That's my recommendation. That's what I've been advising people to do. Take the smaller ones as pilots, roll them out. But that data governance that Simon and I were talking about has to be critical in that process. So you have to analyze every step, but you need a council to do that. And the importance is the structure, right? But what's the ultimate end goal that you want by doing it, even on a small project? You know, most of the time what we see is with these mega projects, what I've found is they're very, very well thought out. There's just dozens upon dozens of volumes of information that's being asked for or requested. But when I ask the question back, what are you gonna do with it? They can't answer me. Put all these stipulations out there, but then they don't know what they're gonna do with that data once they get it all.
We certainly get that and don't want to do that, obviously. So, yeah, thanks.
No, but the thing is, what I want you guys to take away from this, and I think Simon would agree, the ultimate goal is gonna be the management of that asset, right? That's just a fact, and it's just something that we have to come to terms with, deal with, and take into account. The BIM is just one part of the digital twin. That model is one part of the digital twin. But it's a key component, because as I said, it's object-oriented database. So infinite amounts of information can be placed on individual objects and cross-referenced and transferred.
As a follow-up to Bill's question, I think he's trying to ask is, how scalable is it? Is there a break-even point? You know, we know that the megas and the major projects, you know, even $20 million, even a roundabout project, how scalable is it to, what level of effort is needed for, preservation, maintenance, smaller, less than $5 to $10 million projects?
I would say, again, it goes into LOD and the level of effort that you're actually putting into the development of this information model, right? It is scalable, but you have to look at again, what is the use case behind scaling? So a lot of the parameters that I talked about today, or Simon had discussed with these architectures, might not be applicable to the $5 million job. You have to right size it and decide what is the use case that you want to get out of that $5 million. It could just be a bridge rehab. But what we try to encourage people all the time is go get a LiDAR scan of that bridge before you actually start designing it. Know what the real conditions are. Don't use traditional survey. Don't go off your field inspection reports, hand it over and give some RID documents to the design firm and say, okay, have at it. This is accurate information. No, it's not. But it could be a $5 million rehab of a very small overpass or very small bridge, right? But when you're building it out to a three-dimensional model and you have the right level of detail there, there's payback and benefit. Butch, why don't you describe, what you guys are going through right now with your pilot?
Which project? The bridge project?
Yep.
We just, actually, we're currently bidding a models legal document, overhead bridge, 2-lane. Actually, we're getting a lot of questions about that during the bidding process here. But we don't have pay items in this. We made a kind of a field call partway through kind of a leap from our first project, which was just basically a roll plot with a 400-foot reprofile section that was modeled, which we found out they didn't use the model anyway. They had the XML files and stuff that provided a lot of
Yeah.
other information, and they just, the model and viewing it, they weren't having none of it at that point there, so.
And that's part of the problem.
A couple quick questions on that. So, are you requesting a BIM execution plan from?
We have what we call a project execution plan that we do during design, and the goal is just to carry that over into construction and keep, you know.
So that's for you guys in managing this project, right? So this is going out to, okay, so you're letting the project right now, it's out to bid. And was that a consultant designer or in-house?
Consultant, almost everything we do is consultant design, and basically we just work with every project with them. And that what we call PXD can be handed over then to the contractor and stuff. And these are a lot of workflows and processes that we're kind of like experimenting live through the project.
Sure.
But we're given, like during the design, we gave them a heads up and accounted for budget-wise for extra time and work on the consultant side so they didn't get hosed, you know, and
Yeah.
stuff in the process. And probably the same thing will go on to the construction side.
Thank you.
Just curious, like, I know there's a couple situations where you said you LiDAR'd bridges, and can you use those kind of input and outputs as part of your live model to potentially project or predict deterioration?
Yes. Because what we started to find is that LiDAR model is a snapshot in time, but it's a highly detailed, highly accurate snapshot in time. And we utilize that then to go out and do the periodic field inspections that are required, you know, every 2 years for a bridge, for example. We can compare them. So we can see deterioration. We can understand movement and lateral displacement and other things a lot better. And it's a lot safer, to tell you the truth. We're not closing down roadways and putting people in harm's way by closing down roadways and getting them out there. We're you know, flying over with UAS, but the underside of the bridge, we're actually capturing with terrestrial LiDAR to get very high accurate information.
But
And
you can even kind of design for the predicted quantities that you're gonna have by the time you get out to construction.
yeah, yeah. So LiDAR is key, and again, that unstructured data that comes from UAS is so big this year. Last year it was minimal, but it's like massive this year at IHEEP. It's good. It's good for roadway, but I'll tell you what, flying a bridge, especially when you got trucks moving on the bridge moves. And those scanners on your little drone, the drift that you're gonna get is not gonna give you an accurate model. So we combine the unstructured data with the structured data. So we take control into account all the time. So traditional survey methods go into all of our LiDAR practices, and then those LiDAR practices, you know, that's what our group does, is we take that information and build accurate models. I mean, one of the big things that all of you guys probably deal with is that, you know, your ADA ramps, right? We did that for the state of Delaware. We scanned all of them throughout the entire state. Built a digital estate for them. Between the LiDAR and the modeling, everything is geospatially referenced, but one big database.
Mobile LiDAR, would you use?
Terrestrial.
So you set up to shoot all these
Mm-hmm.
curve ramps.
Yep.
It's a lot of data.
Yeah. But it was worthwhile. I mean, it took us, I think, 6 months to get everything modeled in its entirety. But again, it was, you know, for asset management purposes and compliance.
Right.
Any last questions? We want to thank you very much for, I know it was a lot, we tried to compress it all down into a narrow space of time and allow time for questions, so I know it was like drinking water from a fire extinguisher. But thank you very much for being here, and thank you.
Thanks, guys.